Hello there, traveller, and welcome to The Weary Researcher, where we take the most mind-bending questions in the universe and explore them with the gentle curiosity of a midnight wanderer. Tonight, we're embarking on perhaps the most tantalizing journey of all, one that philosophers, dreamers, and physicists have pondered for centuries. What if time travel was actually possible? Before we drift into this cosmic adventure, I'd love to know where in the world you're watching from and what time it is for you right now. It's fitting, isn't it, that a video about time travel finds you scattered across different time zones, each of you arriving at this very moment from your own unique slice of the clock. If you find this exploration of space-time soothing, or perhaps just wonderfully strange, I'd be ever so grateful if you gave the video a like and maybe subscribed. It helps this little corner of cosmic curiosity reach other restless minds who might need a peaceful journey through the mysteries of the universe. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll have learned something extraordinary about the nature of time itself before you finally drift off to sleep. So settle in, close your eyes if you like, and let's begin our gentle voyage through the looking glass of time. Picture this. You wake up tomorrow morning and check your phone, only to discover it's not tomorrow at all. It's yesterday, or perhaps next week, or maybe you're suddenly standing in a world where the pyramids are still being built and the future you came from is nothing but a distant dream. This isn't science fiction. This is the realm of theoretical physics, where the impossible becomes merely improbable, and where Einstein's equations whisper secrets about the true nature of time. Time travel has captured human imagination for as long as we've understood that time moves in one direction. We've all felt that bittersweet ache of wanting to go back to fix a mistake, to say the words we never said, or to simply experience a perfect moment one more time. We've dreamed of stepping into the future to see how our stories end, to witness the marvels that await humanity among the stars. But what if I told you that time travel isn't just the stuff of movies and novels? What if the universe has already provided us with a roadmap written in the language of physics itself? The truth is, time travel is not only theoretically possible, according to our best understanding of physics. It's happening right now all around us, in ways both subtle and profound. Every time you check your GPS, you're relying on calculations that account for time moving differently in space than it does on Earth. Every astronaut who has ever orbited our planet has travelled, however briefly, into the future. And every twin who has ever been separated by high-speed travel has experienced time's malleable nature firsthand. But before we venture into the exotic realms of wormholes and black holes, before we explore the mind-bending implications of travelling faster than light, we need to understand something fundamental about time itself. Time is not the rigid, unchanging river that our everyday experience suggests. It's more like a flowing stream that can be bent, twisted, and even reversed under the right conditions. This revelation began with a young patent clerk in Switzerland, whose wild hair and wilder ideas would forever change how we understand reality. Albert Einstein didn't set out to unlock the secrets of time travel, but in developing his theories of relativity, he accidentally handed humanity the keys to manipulating time itself. His work revealed that time and space are not separate entities, but rather two aspects of a single fabric called space-time. And this fabric can be stretched, compressed, and warped in ways that would make even the most imaginative science fiction writer blush. Einstein's special theory of relativity, published in 1905, tells us something remarkable. The faster you move through space, the slower you move through time. This isn't just theory. It's been measured, tested, and confirmed countless times. If you were to climb aboard a spacecraft and accelerate to 99% the speed of light, time would slow down for you by a factor of 7. What this means is that a journey to a star system 7 light years away would take you only 2 years from your perspective. But when you return to Earth, you'd find that 14 years had passed for everyone else. You'd have quite literally travelled into their future. But Einstein wasn't finished with his assault on our common sense understanding of time. His general theory of relativity revealed that gravity itself warps space-time. The stronger the gravitational field, the slower time moves. This effect, called gravitational time dilation, means that time passes more slowly on the surface of the Earth than it does in orbit, which is why GPS satellites must constantly adjust their clocks to maintain accuracy. Without these adjustments, your GPS would be off by several miles each day, a testament to the very real effects of relativistic time dilation. These aren't abstract mathematical curiosities, they're measurable phenomena that affect our daily lives. Astronaut Scott Kelly, who spent 520 days in orbit, returned to Earth 5 milliseconds younger than he would have been if he'd stayed on the ground. His twin brother Mark, who spent only 54 days in space, experienced less of this time dilation effect, making him technically older than Scott despite being born 6 minutes later. This real-world example proves that humans have already mastered a form of time travel. We're just not very good at it yet. The implications are staggering. Imagine if we could harness these effects on a larger scale. A generation ship travelling at near light speed could carry colonists to distant worlds, while centuries passed on Earth. The travellers would arrive at their destination having aged only years, while Earth would have evolved into something unrecognisable. Or perhaps explorers could venture close to a black hole, where the intense gravitational field would slow time to a crawl, allowing them to observe the distant future of the universe unfold in fast forward. But time travel to the future, while fascinating, is only half the story. What about travelling to the past? What about undoing mistakes, preventing tragedies, or simply satisfying our curiosity about history? This is where physics becomes even stranger, and where the gentle laws of Einstein's relativity give way to more exotic possibilities. Enter the wormhole, a theoretical tunnel through space-time that could connect distant regions of the universe or even different times. Imagine folding a piece of paper so that 2 points touch. A wormhole would be like poking a hole through both layers, creating a shortcut between them. These Einstein-Rosen bridges, as they're formally known, are mathematically allowed by general relativity, though we've never found one in nature. But here's where it gets interesting. If you could manipulate a wormhole in just the right way, you could turn it into a time machine. The process involves taking one end of the wormhole on a high-speed journey while keeping the other end relatively stationary. Due to time dilation, the travelling end would age more slowly than the stationary end, creating a time difference between the two mouths of the wormhole. Step into the fast-moving end, and you could emerge from the stationary end at an earlier time, effectively travelling into the past. Of course, there are a few tiny problems with this scenario. First, we'd need to find or create a wormhole, which would require exotic matter with negative energy density, something that may not exist in our universe. Second, we'd need to prevent the wormhole from collapsing the moment anything tries to pass through it. And third, we'd need to solve the various paradoxes that backward time travel would create. But apart from those minor technical difficulties, the physics checks out. The paradoxes of backward time travel have puzzled scientists for decades. The most famous is the grandfather paradox. If you travelled back in time and prevented your grandparents from meeting, you would never be born. But if you were never born, who went back in time to prevent the meeting? It's a logical loop that seems to break causality itself. Some physicists propose that the universe has a built-in protection against such paradoxes. Stephen Hawking called it the chronology protection conjecture, suggesting that the laws of physics conspire to prevent closed timelike curves from forming. Others invoke the many worlds interpretation of quantum mechanics, arguing that changing the past simply creates a new timeline, rather than altering the original one. In this view, every possible outcome of every decision creates a new branch of reality, meaning time travelers would simply be exploring different versions of history rather than changing their own. But perhaps the most intriguing solution comes from recent quantum research suggesting that time travel might naturally resolve its own paradoxes through quantum effects. Physicists have discovered that on closed timelike curves, quantum fluctuations can actually erase entropy, reversing the normal flow of cause and effect. A time traveler's memories might fade as they journey backward, their very presence in the past becoming self-consistent with the timeline they remember. These ideas push us to the very edges of known physics, into realms where quantum mechanics and general relativity dance together in ways we're only beginning to understand. But they're not pure fantasy. Every equation, every thought experiment is grounded in mathematics that has been tested and verified in other contexts. Consider the Alcubierre drive, a theoretical propulsion system that could enable faster-than-light travel without violating Einstein's speed limits. The drive works by contracting space in front of a spacecraft while expanding it behind, creating a bubble of warped space-time that carries the ship faster than light could travel through normal space. The ship itself never exceeds the speed of light within its bubble, but the bubble can move through space faster than light, creating a loophole in relativity. While the Alcubierre drive doesn't directly enable time travel, it opens up possibilities for closed timelike curves, paths through space-time that loop back to their own past. A sufficiently advanced civilization with access to exotic matter could theoretically create such curves, allowing for backward time travel on a cosmic scale. NASA has actually funded research into the Alcubierre drive, though we're still far from building a working prototype. The energy requirements are staggering, equivalent to the mass energy of Jupiter to move a small spacecraft, and that's assuming we can create the negative energy density required, which remains purely hypothetical. Yet the fact that serious scientists at prestigious institutions are studying these concepts tells us something profound about how far we've come in understanding the nature of reality. What was once pure fantasy is now the subject of peer-reviewed research published in respected physics journals. The universe, it seems, is far stranger and more malleable than our ancestors ever imagined. Time is not a river flowing in one direction, but an ocean with currents and eddies, tides and storms. Space is not an empty stage, but a dynamic medium that can be shaped and moulded by matter and energy. And the boundary between past, present and future may be nothing more than a persistent illusion of human consciousness. As we drift deeper into this exploration of temporal possibilities, we'll discover how black holes could serve as natural time machines, how quantum entanglement might enable communication with the past, and how the very fabric of reality might be structured to allow for time travel while protecting the universe from paradox. We'll meet the scientists who are pushing the boundaries of what's possible and explore the implications of a world where time travel becomes not just theoretically feasible, but practically achievable. But for now, as you lie there in the quiet of your own present moment, remember that you are already a time traveller, moving through the fourth dimension at exactly 1 second per second, carried forward by the gentle current of causality toward whatever wonders await in the vast ocean of tomorrow. And perhaps, just perhaps, those wonders include the ability to navigate that ocean in directions we've only dared to dream. Among the most exotic and fascinating objects in our universe, black holes represent nature's most extreme experiments with space-time. These cosmic monsters, where gravity has collapsed matter into a point of infinite density, create such intense curvature in the fabric of reality that they become natural laboratories for studying the most extreme effects of time dilation. Imagine approaching the event horizon of a black hole, that invisible boundary beyond which nothing, not even light, can escape. As you drift closer, time begins to behave in increasingly strange ways. To an outside observer watching your descent, you would appear to slow down dramatically, your movements becoming more and more sluggish until you seem to freeze at the event horizon like a photograph suspended in space. Meanwhile, from your perspective, time would continue normally, but the universe outside would appear to speed up dramatically. This effect, known as gravitational time dilation, becomes so extreme near black holes that it opens up tantalizing possibilities for time travel. The movie Interstellar captured this beautifully with its water planet, where 1 hour equals 7 years on Earth. While the film took dramatic liberties with the physics, the underlying concept is sound. Near a massive black hole, time can slow to such an extent that what feels like a brief visit could translate to decades or centuries passing in the outside world. But black holes offer more than just extreme time dilation. They may provide pathways to entirely different regions of space-time, or even different times altogether. Rotating black holes, called Kerr black holes, have an even more bizarre property. They drag space-time itself around with them, creating what physicists call frame dragging. This effect means that near a spinning black hole, the very coordinates of space and time become twisted. Within the ergosphere, the region outside the event horizon, where space-time is dragged along with the black hole's rotation, it becomes theoretically impossible to remain stationary relative to distant stars. You're forced to rotate with the black hole, whether you like it or not, but this strange region also offers unique opportunities for energy extraction and potentially for manipulating the flow of time itself. Some theoretical models suggest that the singularity at the center of a rotating black hole might not be a point but rather a ring, and if you could somehow survive the journey through the event horizon, this ring might serve as a gateway to other regions of spacetime, perhaps even to other times. The mathematics are incredibly complex, and the practical challenges are overwhelming, but the possibility exists within the framework of general relativity. Of course, the idea of using black holes for time travel comes with certain drawbacks. The tidal forces near a black hole would tear apart any ordinary matter long before reaching the event horizon, and even if you could somehow survive the journey, there's no guarantee you could return to report your findings. But these obstacles haven't stopped physicists from exploring the theoretical implications. Meanwhile, in the quantum realm, entirely different approaches to time travel are being investigated. Quantum mechanics, with its strange rules about probability and measurement, offers its own pathways through time. Quantum entanglement, that spooky action at a distance that Einstein famously disliked, creates instantaneous connections between particles regardless of the distance separating them. Recent experiments have shown that entangled particles can be manipulated in ways that simulate backward time travel. While we're not sending actual objects or information into the past, these quantum time travel simulations reveal fundamental aspects of how information and causality work at the deepest levels of reality. Researchers at Cambridge University have demonstrated that by carefully manipulating entangled particles, they can create scenarios where cause and effect appear to flow backward. These quantum experiments hint at a deeper truth about the nature of time itself. Perhaps time travel isn't about building massive machines or harnessing exotic matter. Perhaps it's about understanding and manipulating the quantum foundations of reality itself. Some physicists propose that consciousness itself might play a role in determining the flow of time, suggesting that time travel could be as much about psychology as physics. But let's return to more concrete possibilities for manipulating time. The concept of closed timelike curves, mathematical paths through space-time that loop back to their own past, represents one of the most rigorously studied approaches to backward time travel. These curves arise naturally in certain solutions to Einstein's field equations, including the famous Gödel universe, a theoretical space-time where the entire cosmos rotates. While we don't live in a Gödel universe, the mathematics shows that closed time-like curves are not forbidden by the fundamental laws of physics. They may be impractical or unstable, but they're not impossible. This realization has led to serious academic research into the conditions under which such curves might form and the implications they would have for causality and free will. One particularly intriguing proposal involves cosmic strings, hypothetical one-dimensional defects in space-time left over from the early universe. If two cosmic strings were to pass by each other at high speed, they could create a closed timelike curve, allowing for backward time travel. The energy scales involved are enormous, requiring cosmic strings with the mass of entire galaxies, but the physics is sound. Another approach involves manipulating the expansion of space-time itself. The universe is expanding, carrying distant galaxies away from us at ever-increasing speeds. But what if we could create a region where space contracts instead, where the normal expansion is reversed? Such a region might allow for faster-than-light travel and potentially for closed time-like curves. The Alcubierre drive we mentioned earlier represents one such approach. By contracting space in front of a spacecraft and expanding it behind, the drive could propel a ship faster than light without violating relativity. The ship itself never exceeds light speed within its local bubble, but the bubble moves through space faster than light could travel through normal spacetime. While the Alcubierre drive was originally conceived for faster-than-light travel, physicists have realized that with the right modifications, it could enable time travel as well. By creating asymmetric bubbles or by having multiple bubbles interact in specific ways, it might be possible to create closed time-like curves, allowing for backward time travel. The energy requirements remain staggering, requiring exotic matter with negative energy density and control over spacetime curvature on a massive scale. But NASA-funded research has shown that the energy requirements might be reduced from Jupiter-sized to more manageable levels through clever engineering and better understanding of spacetime dynamics. Meanwhile, other physicists are exploring whether quantum effects might naturally create the conditions necessary for time travel. Quantum fluctuations in the vacuum of space occasionally create particles with negative energy. These virtual particles normally annihilate almost immediately, but under the right conditions, they might be stabilized and amplified to create the exotic matter needed for time travel. The Casimir effect demonstrates that negative energy can exist in nature. Two parallel metal plates placed extremely close together in a vacuum will experience an attractive force due to quantum fluctuations. This force arises from negative energy density between the plates, proving that exotic matter isn't just a theoretical possibility, but a measurable phenomenon. Scaling up the Casimir effect to create macroscopic amounts of negative energy remains a monumental challenge, but it shows that the universe already contains the building blocks for time travel. We just need to learn how to harness and amplify them. As we delve deeper into these possibilities, we begin to see that time travel isn't just about exotic physics and impossible engineering. It's about understanding the fundamental nature of reality itself. What is time? What is causality? What does it mean for something to exist in a particular moment? Some physicists argue that time is an emergent property arising from more fundamental processes. Just as temperature emerges from the motion of molecules, or wetness emerges from the behavior of water molecules. In this view, time travel might not require manipulating time directly, but rather manipulating the underlying processes from which time emerges. Others suggest that the block universe model, where all moments in time exist simultaneously and eternally, might make time travel not just possible, but inevitable. In this model, the past, present, and future are all equally real, and time travel becomes simply a matter of accessing different regions of this four-dimensional block. Quantum mechanics adds another layer of strangeness with its many worlds interpretation, suggesting that every quantum measurement creates multiple parallel realities. In this framework, time travel might not change the past, but rather allow access to alternate timelines where events unfolded differently. These ideas push us to the very limits of human understanding, forcing us to question our most basic assumptions about cause and effect, past and future, existence and non-existence. They remind us that the universe is far stranger and more wonderful than our everyday experience suggests. As we continue our journey through the landscape of temporal possibility, we'll explore the practical implications of these discoveries. What would a world with time travel actually look like? How would society change if we could visit the past or skip ahead to the future? What ethical dilemmas would arise? And what new forms of art, science, and human experience might emerge? But for now, as you drift through your own timeline at the stately pace of 1 second per second, remember that every moment you experience is part of a vast cosmic tapestry where past, present, and future dance together in ways we're only beginning to understand. The universe has already shown us that time is malleable, that causality can bend, and that the impossible might just be improbable. In the gentle rhythm of your breathing, in the quiet space between heartbeats, you are participating in the greatest mystery of all, the mystery of time itself. And perhaps, in understanding that mystery, we'll discover not just how to travel through time, but why time exists at all. The practical implications of time travel extend far beyond the realm of theoretical physics into questions that would reshape every aspect of human civilization. Imagine for a moment that tomorrow, scientists announce they've successfully built a working time machine, not the massive cosmic engineering projects we've been discussing, but something achievable within our current technological reach. Perhaps a small chamber that can send objects or even people a few hours or days into the past. The immediate question wouldn't be how it works, but who gets to use it and for what purpose. Would time travel become the ultimate privilege, reserved for the wealthy and powerful, or would it democratize into something as common as air travel? The social implications are staggering. Governments would face unprecedented challenges in regulation and control. How do you police something that can literally undo its own enforcement? Consider the economic ramifications. If insider trading is illegal, what about insider time travel? Someone could observe stock market movements, then travel back to make perfectly informed investments, or imagine the impact on sports betting, on gambling, on any form of speculation based on uncertain outcomes. The entire foundation of risk and reward that underpins modern economics would crumble overnight. But the personal implications might be even more profound. We all carry regrets, words we wish we'd spoken differently, choices we'd make again with the wisdom of hindsight. Time travel would offer the ultimate form of editing, allowing us to revise our life stories like drafts of a novel. Yet this power might prove more curse than blessing. Imagine the psychological burden of living in a world where every mistake could theoretically be undone, where every conversation, every decision, every moment carried the weight of infinite revision. The paralysis of choice that some people experience when ordering from a restaurant menu would pale in comparison to the existential vertigo of unlimited temporal editing. Relationships would transform in ways we can barely imagine. What does it mean to love someone when you can travel back and experience your first meeting infinite times? What does commitment mean when you can always undo any argument, any misunderstanding, any moment of conflict? The very concept of growth through adversity, of learning from mistakes, of accepting consequences, would need to be completely reimagined. Parents might travel back to relive their children's first steps, first words, first days of school. But would those moments retain their preciousness if they could be experienced endlessly, or would the ability to repeat them somehow diminish their meaning? The scarcity that makes moments precious, the irreversibility that gives weight to our choices, might evaporate in a world of infinite temporal possibilities. The legal system would face challenges that make current debates about digital privacy and artificial intelligence seem quaint. How do you prosecute a crime that was undone by time travel? How do you establish guilt when the accused claims they travelled back to prevent the crime from happening in the first place? What does justice mean when victims can be unvictimized and perpetrators can undo their actions? Evidence would become meaningless when it could be retroactively altered or erased. Witness testimony would lose all credibility when witnesses could travel back and change what they observed. The entire concept of truth would need to be redefined in a world where the past is as mutable as the future. Education would undergo a revolution beyond recognition. Why memorize historical dates when you could travel back and witness events firsthand? Why study literature when you could meet Shakespeare and discuss Hamlet over ale in a London tavern? Why learn about scientific discoveries when you could observe Newton under his apple tree or sit with Einstein as he formulates relativity? Yet this raises profound questions about authenticity and understanding. Would experiencing the signing of the Declaration of Independence teach you more about American history than reading about it? Or would your presence as a time-travelling observer fundamentally alter the nature of what you're observing? The observer effect, familiar from quantum mechanics, would take on new dimensions in temporal mechanics. Medicine would face ethical dilemmas that dwarf current debates about genetic engineering and life extension. Should doctors be allowed to travel back and prevent diseases before they develop? Could parents travel to their own childhoods to prevent genetic conditions from being passed down? What about mental health conditions that might be considered part of someone's essential identity? The concept of death itself would require redefinition. If you could travel back and prevent fatal accidents or warn people about impending heart attacks, would death become merely an inconvenience rather than a finality? Or would the universe's apparent protection against paradoxes prevent such interventions, creating new forms of tragedy and helplessness? Privacy would become a relic of a simpler time. Imagine trying to keep secrets when anyone with access to time travel could observe your past actions, your private moments, your most intimate conversations. The very concept of a private life would need to be rebuilt from the ground up, with new technologies and social norms we can barely imagine. Art and creativity would flourish in ways we've never seen. Writers could travel to any time period for research, musicians could jam with Bach or collaborate with Beethoven, filmmakers could capture historical events with unprecedented authenticity. Yet this might also lead to a strange form of creative stagnation. If every story has already been told and every song already written, what motivation would remain for original creation? The scientific method itself would need fundamental revision. If you could travel back and observe any experiment, any natural phenomenon, any moment in cosmic history, the distinction between theoretical and experimental physics would blur beyond recognition. We could witness the Big Bang directly, observe the formation of the first stars, watch evolution unfold in real time. Yet paradoxically, this ultimate empirical tool might lead to new forms of uncertainty. The Heisenberg uncertainty principle suggests that observation changes what we observe. If this applies to time travel, then our attempts to study the past might fundamentally alter it, creating new forms of experimental error that make our current measurement problems seem trivial. Religion and philosophy would grapple with questions that challenge the foundations of human meaning. If time is truly malleable, if the past can be changed, if cause and effect become negotiable, then what does it mean to have faith in divine providence? What does it mean to believe in destiny, or fate, or the inherent meaning of existence? Some might find in time travel the ultimate proof of free will, the ability to literally rewrite history according to our desires. Others might see it as evidence that free will is an illusion, that we're merely actors reading from a script that can be edited but never truly changed, that our sense of agency is nothing more than a persistent delusion. The psychological impact on individuals would be profound. Imagine the guilt of someone who chooses not to travel back and prevent a tragedy they could have stopped. Imagine the burden of someone who travels back repeatedly, trying to create the perfect version of events, only to discover that perfection is eternally elusive. Relationships between different generations would transform in unexpected ways. What happens when children can travel back and meet their parents as young adults? When grandparents can witness their grandchildren's entire lives from beginning to end? When the normal progression of aging and death and generational change becomes optional rather than inevitable? Society might split into temporal classes, those with access to time travel and those without, creating inequalities that make current wealth gaps seem insignificant. The time-rich would have infinite opportunities to accumulate knowledge, wealth, and experience, while the time-poor would be trapped in their original timelines, watching history unfold only once. Yet perhaps the most profound impact would be on our sense of narrative coherence, the stories we tell ourselves about who we are and how we became that way. Currently, our identities are built from the irreversible accumulation of experiences, choices, and consequences. In a world with time travel, identity itself becomes fluid, negotiable, endlessly revisable. We might discover that the linear progression of time that feels so natural to us is actually essential to consciousness itself, that our sense of self depends on the irreversibility of experience, that without the forward arrow of time, memory loses its meaning and personality becomes impossible to maintain. Or we might find that consciousness is far more adaptable than we imagine, that humans can learn to navigate temporal complexity the way we learned to navigate physical space, that new forms of identity and meaning emerge when the constraints of linear time are removed. These questions don't have simple answers because time travel would force us to confront the deepest mysteries of existence. What makes life meaningful? What gives weight to our choices? What creates the precious fragility that makes each moment matter? The answers might surprise us, revealing aspects of human nature we never suspected. As we continue to explore these possibilities, remember that even contemplating them changes us. The mere act of imagining a world with time travel expands our understanding of what it means to be human, of what we value and why we value it. Whether or not time travel ever becomes possible, the questions it raises illuminate the profound mystery of consciousness existing within the flow of time. In the quiet space of your own thoughts, as you drift between waking and sleeping, you are already experiencing time's deepest mystery, the way moments blend into memory, the way the past feels both distant and immediate, the way the future exists as pure possibility waiting to be born into the eternal now of present experience. Perhaps that mystery is more wonderful than any machine we could build, more magical than any portal we could open, because in every breath, every heartbeat, every thought, you are already travelling through time at the cosmic speed limit of 1 second per second, participating in the universe's grandest adventure. The transformation of possibility into memory through the sacred act of simply being present in this moment. As we drift deeper into the labyrinth of temporal mechanics, we encounter perhaps the most mind-bending aspect of time travel research, the delicate dance between quantum mechanics and relativity that might hold the key to unlocking the universe's temporal secrets. Recent breakthroughs in quantum physics have revealed that the microscopic world operates under rules so strange they make traditional time travel paradoxes seem almost mundane by comparison. At the quantum level, particles don't just exist in one place at one time, they exist in what physicists call superposition, occupying multiple states simultaneously until the moment they're observed. This quantum weirdness has led researchers to propose that time travel might not require massive machines or exotic matter at all, but rather a deep understanding of how information flows through the quantum fabric of reality. Picture this: scientists have recently demonstrated that entangled particles can be manipulated to simulate backward time travel, creating scenarios where effect appears to precede cause. While this isn't quite the same as sending your grandmother a warning about that unfortunate investment in the tulip market, it reveals something profound about the malleable nature of causality itself. These quantum time travel experiments work by exploiting the strange property that entangled particles share information instantaneously, regardless of the distance between them. When researchers manipulate one particle, its entangled partner responds immediately, even if it's on the other side of the galaxy. By carefully orchestrating these quantum conversations, scientists can create situations where information appears to flow backward through time, arriving before it was sent. The implications are staggering. If consciousness itself operates through quantum processes, and some researchers believe it does, then perhaps our minds are already navigating multiple timelines simultaneously. Every decision you make might create a branching pathway through time, with your consciousness experiencing just one branch, while countless alternate versions of yourself explore different possibilities. This brings us to one of the most elegant solutions to the grandfather paradox, the many worlds interpretation of quantum mechanics. In this view, traveling back in time doesn't change your original timeline, it creates a new one. When you prevent your grandparents from meeting, you're not erasing yourself from existence, you're simply creating a new branch of reality where you were never born. Your original timeline continues unchanged, while you become a visitor in an alternate history. This quantum approach to time travel resolves many of the logical contradictions that have plagued temporal mechanics for decades. Instead of fighting against paradoxes, the universe simply creates new realities to accommodate them. Every time traveler becomes an explorer of infinite possibility, navigating between worlds that exist in parallel dimensions of space-time. But quantum mechanics offers more than just elegant solutions to paradoxes. It provides practical pathways toward achieving time travel itself. Researchers have discovered that quantum fluctuations in the vacuum of space occasionally create particles with negative energy, the same exotic matter required for stabilizing wormholes and creating closed, timelike curves. These quantum fluctuations are normally tiny and short-lived, lasting only fractions of a second before disappearing back into the quantum foam. But theoretical work suggests that under the right conditions, these fluctuations could be amplified and stabilized, creating macroscopic amounts of the negative energy needed for time travel. It's like finding tiny seeds of temporal possibility scattered throughout the universe, waiting for the right gardener to cultivate them into full-grown time machines. The Casimir effect, which we touched on earlier, demonstrates that this isn't pure fantasy. When two metal plates are placed incredibly close together in a vacuum, quantum fluctuations create a measurable, attractive force between them. This force arises from negative energy density, proving that the universe already contains the ingredients for time travel. We just need to learn how to harvest them on a larger scale. Some physicists propose that advanced civilizations might create vast networks of quantum amplifiers, devices that capture and concentrate these natural fluctuations into usable, exotic matter. These cosmic engineering projects would dwarf anything humanity has ever attempted, requiring the coordinated effort of entire civilizations over thousands of years. Yet the physics suggests it's possible, even if it remains far beyond our current capabilities. Meanwhile, other researchers are exploring whether consciousness itself might provide a pathway to time travel. If our minds operate through quantum processes, as some theories suggest, then perhaps we're already unconsciously accessing information from multiple timelines. Dreams, intuitions, and moments of déjà vu might be glimpses of alternate realities bleeding through the quantum barriers that normally separate different branches of time. This idea leads to fascinating speculation about the nature of memory and experience. What if the feeling that you've lived through a moment before isn't just a neurological glitch, but an actual memory from an alternate timeline? What if prophetic dreams and psychic intuitions are real phenomena caused by quantum information leaking backward through time from possible futures? These concepts push us into territory where science meets spirituality, where the hard mathematics of physics encounters the soft mysteries of consciousness. Some researchers propose that meditation and other consciousness-altering practices might enhance our natural ability to perceive multiple timelines, turning time travel from a technological challenge into a mental discipline. The implications for human potential are extraordinary. If we could learn to consciously navigate between different branches of reality, we might gain access to the accumulated wisdom of countless alternate selves. Every decision not made, every path not taken, might become available for exploration and learning. The phrase "what if" would take on literal meaning as we explore the infinite garden of possibility that quantum mechanics reveals. But this quantum approach to time travel comes with its own challenges and limitations. Quantum decoherence, the process by which quantum superposition collapses into classical reality, might prevent macroscopic objects like humans from maintaining the delicate quantum states necessary for timeline hopping. We might find that consciousness can slip between realities while bodies remain trapped in single timelines. This leads to intriguing possibilities for what we might call quantum time travel, a form of temporal exploration that involves consciousness rather than physical matter. Imagine being able to access the memories and experiences of alternate versions of yourself, learning from choices you made in other timelines without physically traveling to those realities. Such abilities might already exist in rudimentary form. The phenomenon of parallel processing in the brain, where multiple neural networks work on problems simultaneously, might be accessing quantum computations that span multiple timelines. Creative insights that seem to come from nowhere might actually be memories borrowed from alternate selves who explored different paths through life. As we venture further into this quantum landscape of temporal possibility, we begin to see that time travel might not be about building machines at all, but about understanding the deepest nature of reality itself. The universe appears to be constructed in layers, with classical physics governing our everyday experience, while quantum mechanics orchestrates a hidden ballet of infinite possibility beneath the surface. Each moment you experience might be just one note in a vast symphony of alternate realities, each playing out different variations on the theme of your life. Time travel, in this view, becomes less about changing the past and more about learning to hear the other melodies that are always playing alongside your own. The gentle rhythm of your breathing, the soft whisper of air moving through your lungs, might be synchronized with the quantum heartbeat of the universe itself. In the space between thoughts, in the pause between one heartbeat and the next, infinite possibilities dance on the edge of becoming real. Recent theoretical work has suggested that the structure of space-time itself might be built from quantum entanglement, with the familiar 3 dimensions of space and 1 dimension of time emerging from a deeper quantum reality. If this is true, then understanding time travel requires understanding the quantum foundations of existence itself. This quantum theory of space-time suggests that what we experience as the flow of time might be an emergent property arising from the collective behavior of countless quantum interactions, like temperature emerging from the motion of molecules, or wetness emerging from the behavior of water molecules. Time might be a large-scale pattern that emerges from quantum processes too small and fast for us to perceive directly. In this view, time travel becomes a matter of accessing the quantum substrate that underlies our classical reality. Instead of needing exotic matter or cosmic engineering, we might need quantum computers capable of manipulating the fundamental information structure of spacetime itself. These devices would operate not by moving through time, but by rewriting the quantum code that creates our experience of temporal flow. Such quantum time machines might work by creating controlled entanglement between different moments in space-time, allowing information to flow between past and future through quantum channels that bypass the normal restrictions of causality. The traveller wouldn't physically move through time, but would become quantum entangled with their destination moment, experiencing it as directly as their present reality. This approach to time travel offers elegant solutions to many of the practical problems we've discussed. Since only information travels through the quantum channels, there are no issues with energy conservation or the transportation of matter. The traveller's consciousness could explore different timelines while their body remains safely in the present, eliminating the physical dangers of temporal displacement. The technology required for such quantum time travel might not be as far-fetched as cosmic engineering projects involving black holes or wormholes. Quantum computers are already being developed that can manipulate entangled particles with incredible precision. As these devices become more sophisticated, they might eventually achieve the level of quantum control necessary for temporal manipulation. Some researchers speculate that sufficiently advanced quantum computers might naturally create closed timelike curves as a side effect of their operation. The complex quantum calculations required for certain problems might inadvertently open pathways through time, allowing information to flow backward and forward through the computational process. This possibility has led to serious discussions about the safety protocols that might be needed for future quantum computers. If these devices could accidentally create time travel effects, we would need safeguards to prevent paradoxes or unintended alterations to the timeline. The field of quantum computing might need to develop temporal firewalls and causality protection systems to ensure that our quest for computational power doesn't inadvertently unravel the fabric of time itself. As we contemplate these quantum pathways to time travel, we're reminded that the universe operates on principles far stranger and more wonderful than our everyday experience suggests. The solid reality of tables and chairs, the steady flow of seconds and minutes, the clear distinction between past and future, all of these familiar aspects of existence might be elaborate illusions created by our limited perspective on a far more fluid and interconnected quantum reality. In the gentle space of half-sleep, as your consciousness drifts between waking and dreaming, you might already be experiencing a form of quantum time travel. The bizarre logic of dreams, where past and future blend together in impossible narratives, might reflect the true nature of time at the quantum level. Perhaps sleep is our natural access point to the quantum realm, where the normal rules of causality relax and consciousness can explore the infinite garden of possibility that quantum mechanics reveals. The soft boundary between sleeping and waking, between memory and imagination, between what was and what might have been, mirrors the fuzzy quantum boundaries that might govern the deepest levels of reality. In learning to navigate these liminal spaces with awareness and intention, we might be taking the first steps toward a more quantum understanding of time and consciousness. As you drift deeper into the realm of dreams, remember that every possibility you explore in sleep, every alternate reality you visit in imagination, might be a real destination in the vast quantum landscape of space-time. The universe, it seems, is far more generous with its gifts of possibility than we ever dared to imagine, offering infinite pathways through time for those who learn to see beyond the classical illusion of linear causality. As we venture deeper into the realm of theoretical possibilities, we encounter what might be the most practical pathway to time manipulation that science has yet discovered: the fascinating world of closed timelike curves and the cosmic phenomena that could create them naturally. These aren't the products of advanced alien civilizations or impossible engineering feats, but rather the inevitable consequences of extreme conditions that already exist scattered throughout our universe. Consider cosmic strings, those theoretical one-dimensional defects in space-time that might have formed during the universe's first moments after the Big Bang. If these cosmic strings exist, and many physicists believe they do, they would be among the most exotic objects in the universe, thinner than a proton, but potentially stretching across entire galaxies, carrying the mass-energy equivalent of billions of suns compressed into lines so narrow they're essentially mathematical abstractions given physical form. When two cosmic strings pass by each other at relativistic speeds, something extraordinary happens. The intense gravitational fields they carry begin to interact, warping space-time in ways that create what physicists call a closed timelike curve, a pathway through space and time that loops back on itself. An observer following this path would find themselves returning to their own past, having completed a journey through time itself. The mathematics are elegant in their simplicity, yet the implications are staggering. These cosmic strings, if they exist, would be natural time machines scattered throughout the universe, like temporal highways waiting for travelers bold enough to navigate them. No exotic matter required, no impossible engineering projects, just the patient work of finding these cosmic artifacts and learning to use them safely. But cosmic strings represent just one of several natural phenomena that could enable time travel. The universe, it seems, has been experimenting with temporal mechanics for billions of years, creating laboratories where the normal rules of cause and effect break down in fascinating ways. Rotating black holes, as we've touched on before, create their own forms of temporal distortion through the frame-dragging effects of their immense gravitational fields. Within the ergosphere of a rotating black hole, space-time itself is dragged along with the black hole's spin, creating regions where the distinction between space and time becomes fluid. Theoretical calculations suggest that under precisely the right conditions, these regions might harbour closed time-like curves, allowing for backward time travel. The challenge, of course, lies in accessing these regions without being torn apart by tidal forces or lost beyond the event horizon. Yet even more intriguing are the possibilities offered by the universe's expansion itself. We live in a cosmos that is not only growing larger, but accelerating in its expansion, driven by the mysterious force we call dark energy. This cosmic expansion creates its own temporal effects, and some physicists have proposed that by manipulating the local expansion rate of spacetime, we might create regions where time flows differently or even backward. Imagine a technology that could create a bubble where spacetime contracts while the surrounding universe continues to expand. Within such a bubble, the normal flow of time might reverse, allowing for backward time travel without violating the fundamental laws of physics. The energy requirements would be enormous, comparable to the output of entire stars, but the physics appears sound. This brings us to a sobering realization about the nature of time travel research. Most of the pathways we've discovered require energies and technologies that dwarf anything in human experience. Whether we're talking about stabilizing wormholes, manipulating cosmic strings, or creating bubbles of contracting spacetime, the energy scales involved are typically measured in terms of the stellar masses or galactic outputs. Yet this shouldn't discourage us from pursuing these investigations. Human history is filled with discoveries that seemed impossibly far-fetched until the moment they became routine. The idea of splitting atoms seemed absurd until it powered cities. The notion of instant global communication appeared magical until it became mundane. Perhaps time travel will follow a similar trajectory, moving from impossibility to inevitability through the patient accumulation of knowledge and capability. Moreover, the universe itself provides us with examples of how these extreme energy requirements might be met. Gamma-ray bursts, the most energetic events known to science, release more energy in a few seconds than our sun will produce in its entire lifetime. Quasars, powered by supermassive black holes, outshine entire galaxies through the simple process of matter falling into gravitational wells. The cosmos is no stranger to extreme engineering projects. A sufficiently advanced civilization might learn to harness these cosmic phenomena, using the energy output of entire star systems to power their temporal experiments. They might construct arrays of artificial black holes, each precisely positioned to create the gravitational fields necessary for stable time travel. They might learn to manipulate the expansion of space-time itself, creating pocket universes where time flows according to their intentions, rather than the universe's default settings. But perhaps most intriguingly, some recent theoretical work suggests that the energy requirements for time travel might not be as prohibitive as once thought. Advances in our understanding of quantum field theory and the structure of space-time have revealed potential shortcuts and efficiencies that could dramatically reduce the energy costs of temporal manipulation. The Alcubierre drive, for example, originally required energy equivalent to the mass of Jupiter to propel a small spacecraft faster than light. But refined calculations have shown that clever engineering and better understanding of space-time geometry could reduce these requirements to more manageable levels, perhaps the energy output of a large power plant rather than an entire planet. Similar refinements might apply to time travel technologies. What appears impossible with our current understanding might become merely difficult as our knowledge advances. The history of physics is filled with examples of seemingly insurmountable barriers that dissolved when viewed from new perspectives. Consider the development of nuclear energy. In the early 20th century, the idea of extracting useful energy from atomic nuclei seemed absurd. The energy scales involved were too small, the processes too inefficient, the technological challenges too great. Yet within a few decades, nuclear power was lighting cities and propelling submarines across the ocean floor. Perhaps time travel will follow a similar trajectory. Today's impossibilities might become tomorrow's engineering challenges, and tomorrow's engineering challenges might become next century's everyday technologies. The key lies not in abandoning the quest, because the challenges seem overwhelming, but in continuing to push the boundaries of what we know and what we can imagine. This brings us to a crucial insight about the nature of time travel research. It's not just about building machines or manipulating exotic matter. It's about expanding our understanding of reality itself. Every equation we solve, every thought experiment we conduct, every paradox we resolve brings us closer to comprehending the true nature of time and causality. And in that quest for understanding, we're already achieving a form of time travel. Through our telescopes, we peer into the past, observing galaxies as they were billions of years ago when the universe was young. Through our particle accelerators, we recreate conditions that existed microseconds after the Big Bang, bringing the distant past into our present laboratories. Through our theories and calculations, we explore possible futures, mapping out the trajectories that reality might follow. We model the evolution of stars, predict the fate of the universe, and glimpse the ultimate destiny of everything we know. In a very real sense, science is already a form of time travel, allowing us to transcend the limitations of our brief existence and explore the full sweep of cosmic history. This perspective offers a different way of thinking about time travel research. Rather than focusing solely on the practical goal of building working time machines, we might consider the journey itself as valuable. Every step we take toward understanding temporal mechanics expands our knowledge of the universe and our place within it. The questions that time travel research forces us to confront, the nature of causality, the relationship between consciousness and time, the meaning of existence in a universe where past and future might be equally real. These are among the deepest and most important questions we can ask. In pursuing them, we're not just trying to build better technology, we're trying to understand what it means to be conscious beings existing within the flow of time. As you drift through your own personal timeline, moving forward at the cosmic speed limit of 1 second per second, remember that you're participating in the greatest experiment ever conceived, the universe's ongoing exploration of its own possibilities. Every moment you experience, every choice you make, every dream you dream adds another thread to the vast tapestry of existence. And perhaps that participation is itself a form of time travel. Not the dramatic variety of science fiction, where heroes leap between centuries in gleaming machines, but the subtle, profound kind where consciousness itself becomes a vehicle for exploring the infinite possibilities that quantum mechanics and relativity reveal. In the gentle space between one heartbeat and the next, in the quiet moment before sleep claims you completely, you're already travelling through time at the only speed that matters, the speed of experience itself. And in that journey, however brief and local it might seem, you're connected to the grandest adventure the universe has ever undertaken, the slow, patient work of transforming possibility into memory, one moment at a time. So what would happen if we actually cracked the code? If tomorrow morning, scientists announced they built a working time machine that could send someone back a few hours, or perhaps forward to next week? The immediate aftermath wouldn't be celebration. It would be chaos on a scale humanity has never experienced. Imagine the first successful test. A brave volunteer steps into the machine and disappears, only to reappear moments later, with proof they've witnessed events that haven't happened yet. The implications would ripple outward like shockwaves through every institution, every assumption, every carefully constructed belief about how reality works. Financial markets would collapse within hours as traders grapple with the implications of being able to observe future stock prices. How do you price risk when risk itself becomes meaningless? How do you invest in uncertainty when certainty becomes purchasable? The entire foundation of economics, the idea that the future is unknown and therefore valuable to predict, would crumble like a house of cards in a hurricane. Governments would scramble to establish control, but how do you regulate something that can undo its own regulation? Traditional law enforcement becomes laughably inadequate when criminals can travel back and erase their crimes from existence. Evidence becomes meaningless when it can be retroactively altered. The concept of justice itself requires fundamental redefinition when victims can be unvictimized and perpetrators can unmake their actions. But perhaps most profoundly, the revelation that time travel is possible would shatter our understanding of free will and personal responsibility. If every choice can be undone, if every mistake can be erased, if every path not taken can still be explored, then what gives weight to our decisions? What makes any particular moment or choice meaningful when infinite alternatives remain perpetually available? The psychological impact on individuals would be staggering. Imagine the paralysis of knowing that every word you speak, every relationship you form, every career path you choose could be revised endlessly. The burden of infinite possibility might prove more crushing than the limitations we currently accept. Some people might spend their entire lives trapped in loops of revision, constantly travelling back to perfect moments that can never be perfected enough. Others might find liberation in temporal fluidity, embracing the ability to explore every facet of existence. They might become temporal nomads, living dozens of different lives across multiple timelines, accumulating experiences and wisdom impossible within the constraints of linear time. But would these time-rich individuals still be recognizably human, or would they evolve into something altogether different? Society would likely stratify along temporal lines. Those with access to time travel would accumulate advantages impossible for others to match. They could study for exams with perfect foreknowledge of the questions, invest with complete certainty about outcomes, and develop relationships with full awareness of their consequences. Meanwhile, Those locked into single timelines would become a kind of temporal underclass, experiencing life only once while others enjoy infinite revisions. The concept of privacy would become meaningless. How do you keep secrets when anyone can travel back and observe your most intimate moments? How do you maintain personal boundaries when your past becomes accessible to others? New forms of temporal surveillance might emerge, with authorities monitoring not just present behavior, but past actions across multiple timelines. Education would transform beyond recognition. Why memorize historical facts when you could witness events firsthand? Why study literature when you could collaborate with the authors themselves? But this raises profound questions about authenticity and understanding. Would experiencing the signing of the Declaration of Independence teach you more about American history than studying it? Or would your presence as a time-traveling observer fundamentally alter the nature of what you're witnessing? Medical ethics would face unprecedented dilemmas. Should doctors be allowed to travel back and prevent diseases before they develop? Could parents visit their own childhoods to prevent genetic conditions from being passed down? What about psychological conditions that might be considered part of someone's essential identity? Depression, anxiety, neurodivergence? The line between treatment and temporal eugenics would blur in disturbing ways. The arts would explode with new possibilities as creators gain access to any historical period for research and inspiration. Musicians could jam with their heroes from any era. Writers could interview historical figures directly. And filmmakers could capture actual events with unprecedented authenticity. Yet this might also lead to creative stagnation. If every story has already been told and every song already written across multiple timelines, what motivation remains for original creation? Religion and philosophy would grapple with questions that challenge the foundations of human meaning. If time is truly malleable, if the past can be changed, if cause and effect become negotiable, then what does it mean to have faith in divine providence? What does it mean to believe in destiny when every destiny can be rewritten? Some might find in time travel the ultimate proof of free will, the ability to literally rewrite history according to our desires. Others might see it as evidence that free will is an illusion, that we're merely actors reading from scripts that can be edited but never truly changed. The relationship between memory and identity would require complete reconceptualization. Currently, we understand ourselves through the accumulation of irreversible experiences, childhood memories, formative relationships, moments of triumph and failure that shape who we become. In a world with time travel, identity becomes fluid, constantly revisable. You might remember multiple versions of your childhood, several different first loves, various career paths, all equally real and personal. Parenthood would transform in ways both beautiful and terrifying. Parents could relive their children's milestones endlessly. First steps, first words, graduation days. But would these moments retain their preciousness if they could be experienced infinite times? The scarcity that makes memories precious might evaporate, replaced by an overwhelming abundance that somehow feels empty. The concept of death would require redefinition. If you could travel back and prevent fatal accidents, warn people about impending heart attacks, or intervene in tragic circumstances, would death become merely an inconvenience rather than a finality? Yet the universe's apparent protection against paradoxes might prevent such interventions, creating new forms of tragedy where you can witness but not prevent suffering. Perhaps most disturbing would be the potential for temporal abuse. Imagine stalkers who could follow their victims through time, experiencing every moment of their lives. Consider the implications of temporal harassment, where someone could repeatedly return to traumatic moments in another person's history. New forms of psychological warfare might emerge, with enemies able to attack not just in the present, but across entire lifetimes. The very concept of truth would need reconstruction. In a world where the past is mutable, how do we establish what really happened? Evidence becomes meaningless when it can be retroactively altered. Witness testimony loses all credibility when witnesses can travel back and change what they observed. Courts might need to develop entirely new standards for determining facts in cases involving temporal manipulation. International relations would face challenges that make current geopolitical complexities seem quaint. How do you maintain treaties when one party can travel back and prevent the circumstances that led to the agreement? How do you wage war when your enemy might undo every victory by altering the past? The entire concept of historical precedent, the foundation of international law, would crumble when history itself becomes negotiable. Yet amid all this chaos and uncertainty, perhaps we would discover something remarkable about human nature. Maybe we would learn that meaning doesn't come from the irreversibility of our choices, but from the act of choosing itself. Maybe we would find that love doesn't depend on the uniqueness of shared moments, but on the decision to share them. Maybe we would realize that growth comes not from accepting consequences, but from the conscious decision to become better versions of ourselves. The universe might teach us that the true miracle isn't time travel itself, but consciousness, the ability to experience moments fully, to find meaning in existence, to create beauty and connection, regardless of whether those moments can be repeated or revised. Perhaps in learning to navigate temporal complexity, we would discover that the essence of being human transcends any particular timeline. As you drift through your own thoughts, carried gently towards sleep by the soft rhythm of your breathing, consider that you are already living within the greatest temporal mystery of all. Every moment of consciousness is a form of time travel, transforming future possibilities into present experiences and then into past memories. The miracle isn't that we might someday build machines to manipulate time. It's that we are already miraculous beings, capable of experiencing the flow of moments with awareness, wonder, and love. In the gentle space between one breath and the next, you are participating in the universe's most elegant experiment, the transformation of pure possibility into lived experience. Whether or not we ever master the technology of time travel, we are already masters of something far more profound, the art of being present in the flowing river of time, finding meaning and beauty in each irreplaceable moment as it unfolds. The soft whisper of night air through your window, the quiet settling of your home around you, the steady rhythm of your heart marking time like a gentle metronome. These are the sounds of time itself, carrying you forward through the darkness toward whatever wonders await in the vast ocean of tomorrow. And perhaps that journey, however brief and local it might seem, is the most beautiful form of time travel we could ever hope to achieve. But what if the answer to time travel lies not in the grand cosmic engineering projects we've been exploring, but in something far more intimate and immediate, the very nature of consciousness itself? Recent research at the intersection of neuroscience and quantum physics suggests that our minds might already be natural time machines, constantly navigating between past memories and future possibilities in ways that mirror the temporal mechanics we've been discussing. Consider how memory works in your brain right now. When you recall a childhood's summer afternoon, you're not simply accessing stored data like a computer retrieving a file. Instead, your brain reconstructs that moment from scattered fragments. The smell of honeysuckle, the feel of warm grass, the sound of distant laughter, weaving them together into a coherent experience that feels as real as the present moment. In a very literal sense, you're time traveling to that afternoon, bringing it forward into your current awareness. But memory doesn't just reach backward through time. Your brain is constantly generating predictions about the future, creating what neuroscientists call prospective memory, detailed mental simulations of events that haven't happened yet. When you imagine tomorrow's breakfast or next year's vacation, You're engaging in a form of forward time travel, exploring possible futures before they become present realities. This bidirectional flow of consciousness through time might be more than just metaphor. Some researchers propose that awareness itself operates through quantum processes that transcend the classical boundaries between past, present, and future. If consciousness involves quantum entanglement between neurons, as some theories suggest, then perhaps our minds naturally access information from multiple temporal states simultaneously. The phenomenon of déjà vu, that eerie feeling that you've experienced something before, might be more than just a neurological glitch. What if it's actually a memory, bleeding through from an alternate timeline? A moment when your quantum consciousness briefly accessed a parallel version of events. The strange familiarity you sometimes feel in new places. The uncanny accuracy of certain intuitions. The prophetic quality of some dreams. All of these might be glimpses of your mind's natural ability to navigate the quantum landscape of possibility. This quantum theory of consciousness suggests that time travel might not require building machines at all, but rather learning to consciously access abilities we already possess. Meditation practices from various traditions speak of transcending linear time, of experiencing past and future as equally present. Perhaps these aren't just spiritual metaphors, but practical instructions for activating our brain's quantum, temporal capabilities. Imagine if we could learn to enhance these natural abilities through training and technology. Brain-computer interfaces might amplify our quantum consciousness, allowing us to consciously explore alternate timelines. Virtual reality systems could simulate the experience of moving through time, while our enhanced awareness actually accesses information from different temporal states. The line between simulation and reality would blur as we discover that consciousness itself is the ultimate time machine. But this raises profound questions about the nature of identity and free will. If your consciousness can access memories from alternate versions of yourself, which experiences are truly yours? If you can perceive multiple possible futures, how do you choose which one to make real? The self that goes to sleep tonight might wake up tomorrow with memories from a dozen different timelines, each equally valid and personal. This multiplicity of experience might actually be liberating rather than confusing. Instead of being trapped by the limitations of a single timeline, you could draw wisdom from the accumulated experiences of countless alternate selves. Every mistake you didn't make, every opportunity you didn't take, every path you didn't follow would become available for learning and growth. Your consciousness would become a library of infinite possibility, constantly expanding as you explore new branches of reality. The implications for human potential are staggering. Creative breakthroughs might come from accessing the innovations of alternate selves. Problem solving could involve consulting versions of yourself who took different educational paths or lived in different historical periods. Emotional healing might include integrating experiences from timelines where traumatic events were prevented or resolved differently. Yet this quantum approach to time travel also comes with its own form of temporal responsibility. If consciousness can influence which possibilities become real, then every thought, every choice, every moment of awareness becomes an act of cosmic creativity. You wouldn't just be observing different timelines, you'd be actively participating in their creation, helping to determine which version of reality unfolds. This brings us to a startling possibility. Perhaps time travel has always been possible, and we've simply forgotten how to use it. Ancient texts speak of seers and prophets who could perceive future events, of wise men who seemed to possess knowledge from beyond their time. What if these weren't supernatural abilities, but natural functions of human consciousness operating at its full potential? Children often display what adults dismiss as imagination: invisible friends who seem remarkably real, detailed knowledge of historical periods they've never studied, uncanny insights about future events. Perhaps children's minds are naturally more open to quantum temporal experiences, only to have these abilities suppressed as they learn to conform to adult expectations of linear time. The process of aging itself might involve a gradual disconnection from our quantum temporal abilities. As we accumulate memories and develop fixed patterns of thinking, we might lose the fluid temporal awareness that comes naturally to younger minds. Learning to time travel might not require building new capabilities, but rather remembering and reactivating dormant ones. This perspective reframes the entire question of time travel from a technological challenge to a consciousness expansion project. Instead of asking how to build machines that can manipulate space-time, we might ask how to develop minds that can consciously navigate the quantum realm where all times exist simultaneously. The answer might lie not in particle accelerators and exotic matter, but in meditation, dreams, and the cultivation of awareness itself. But even if consciousness-based time travel becomes possible, it would raise ethical questions just as complex as those posed by mechanical time machines. If you could access memories from alternate selves, would you have the right to use knowledge gained from their experiences? If you could influence which timeline becomes real through the power of awareness, what responsibility would you bear for the consequences of your choices? The temptation to use temporal consciousness for personal gain would be enormous. Imagine knowing which stocks to buy based on information from your financially successful alternate self, or avoiding relationship mistakes by learning from versions of yourself who made different choices. Yet such use might violate the autonomy of others who don't have access to the same temporal information, creating new forms of inequality and exploitation. Perhaps more troubling would be the potential for temporal addiction. If consciousness could access infinite pleasant experiences from alternate timelines, would there be any motivation to engage with present reality? People might become lost in exploration of perfect moments that exist only in parallel possibilities, neglecting the actual world that needs their attention and care. The social implications would be just as profound as those of mechanical time travel. How would relationships function if partners could access memories of being together in alternate timelines? Would love mean the same thing if you could experience every possible version of a relationship simultaneously? The unique preciousness of shared experiences might dissolve into an overwhelming abundance of possibilities. Educational systems would need complete reconstruction if students could access knowledge from alternate selves who pursued different studies. Why struggle through calculus when you could simply remember understanding it from a timeline where you became a mathematician? Yet this ease of acquisition might paradoxically impoverish learning, removing the struggle and growth that comes from earning knowledge through effort. The legal system would face challenges even more complex than those posed by mechanical time travel. How do you prosecute someone for crimes if they claim to remember committing different actions in their original timeline? How do you establish identity when consciousness can access experiences from multiple versions of the same person? The very concept of individual responsibility would require redefinition in a world of quantum temporal awareness. Mental health professionals would encounter entirely new categories of psychological experience. Imagine treating someone who remembers being traumatized in one timeline but healed in another, or helping a patient integrate conflicting memories from multiple versions of their childhood. The therapeutic process would need to expand to encompass not just personal history, but the entire quantum landscape of possible histories. Yet perhaps the most profound impact would be on our understanding of death itself. If consciousness can access experiences from multiple timelines, then perhaps the end of one particular timeline doesn't represent the end of awareness, but simply a transition to exploring other possibilities. Death might become not a termination, but a graduation to a more expanded form of temporal existence. This quantum view of consciousness and time travel suggests that the universe might be far more generous with its gifts than we ever imagined. Instead of requiring impossible technologies or cosmic engineering projects, time travel might be as natural and available as thought itself. The key would lie not in manipulating external reality, but in expanding internal awareness to embrace the full quantum nature of existence. As you drift deeper into the realm of dreams, where the normal rules of time and space already dissolve into fluid possibility, remember that you might be accessing the most advanced time travel technology ever discovered: your own consciousness. The strange narratives of dreams, where past and future blend in impossible ways, might be glimpses of your mind's natural ability to navigate the quantum landscape of all possible experiences. In the gentle transition between waking and sleeping, as your awareness shifts from the linear demands of daily life to the quantum freedom of the dream state, you're already practicing a form of time travel that makes any mechanical device seem crude by comparison. Your consciousness is the ultimate temporal vehicle, capable of visiting any moment that ever was or might be, limited only by your willingness to explore the infinite possibilities that quantum mechanics reveals. The soft rhythm of your breathing carries you not just forward through linear time, but deeper into the quantum realm where all possibilities exist simultaneously. Each exhalation releases attachment to any single timeline. Each inhalation draws you closer to the vast ocean of potential experiences that await exploration. You are, in this very moment, both the time traveler and the journey itself, consciousness exploring its own infinite nature through the gentle art of simply being aware. In the quiet space between thoughts, in the pause between one heartbeat and the next, you touch something eternal, the timeless awareness that observes all temporal experience without being bound by any of it. Perhaps this is the deepest truth about time travel. It's not about going somewhere else when, but about recognizing that all whens exist within the eternal now of consciousness itself. The past lives in your memory, the future gestates in your imagination, and the present unfolds in your awareness, all 3 times existing simultaneously in the quantum field of your mind. As sleep approaches and the boundaries between possible and actual begin to blur, you're entering the most natural time travel state available to human consciousness. In dreams, you'll visit impossible places, meet people from across your entire timeline, and experience events that follow the logic of quantum possibility rather than classical causality. This nightly journey into temporal fluidity might be preparing you for something far more significant than simple rest. It might be training your consciousness for the day when humanity learns to navigate time as naturally as we now navigate space. And so, as we drift to the end of our gentle journey through the labyrinth of temporal possibility, we find ourselves not with definitive answers, but with something far more precious, a deeper appreciation for the profound mystery that surrounds us every moment of our lives. We've wandered through the mathematics of Einstein's relativity, explored the quantum mechanics of consciousness, and contemplated futures where humanity learns to navigate time as skillfully as we now traverse the surface of our planet. The truth is that whether or not we ever build working time machines, whether we ever master the art of consciousness-based temporal travel, the questions we've explored tonight have already changed us. Simply by contemplating the possibility of time travel, we've expanded our understanding of what it means to be human, what it means to exist within the flowing river of causality, what it means to find meaning and beauty in a universe where past, present, and future might all be equally real. We've discovered that time travel isn't just about building machines or manipulating exotic matter. It's about understanding the deepest nature of reality itself. Every equation we've discussed, every thought experiment we've conducted, every paradox we've pondered brings us closer to comprehending the true fabric of existence. And in that quest for understanding, we're already achieving a form of time travel. Through our telescopes, we peer into the past, observing galaxies as they were billions of years ago when the universe was young and strange. Through our particle accelerators, we recreate conditions that existed in the first moments after the Big Bang, bringing the distant past into our present laboratories. Through our theories and calculations, we explore possible futures, mapping out the trajectories that reality might follow in decades or centuries to come. In a very real sense, science is already a form of time travel, allowing us to transcend the limitations of our brief existence and explore the full sweep of cosmic history. We are temporal archaeologists, uncovering the secrets of what was, temporal architects, designing blueprints for what might be, and temporal philosophers, pondering the meaning of our brief dance within the eternal flow of moments. But perhaps the most beautiful realization from our exploration tonight is that you, dear listener, are already the most sophisticated time machine ever discovered. Your consciousness, with its ability to remember the past, imagine the future, and experience the eternal now of present awareness, represents a form of temporal navigation that makes any mechanical device seem crude by comparison. In the soft space between one thought and the next, you touch something timeless, the awareness that observes all temporal experience without being bound by any particular moment. Your memory carries the past forward into the present. Your imagination draws possible futures into your current experience, and your consciousness weaves all of these temporal threads into the unified tapestry of your lived experience. Every night, as you drift into sleep, you engage in a form of time travel that would be the envy of any science fiction writer. Your dreams blend past and future in impossible narratives, create scenarios that follow quantum logic rather than classical causality, and allow you to experience multiple realities simultaneously. The strange, familiar feeling of déjà vu, the prophetic quality of certain dreams, the way childhood memories can feel more vivid than yesterday's events. All of these might be glimpses of your mind's natural ability to navigate the quantum landscape of temporal possibility. As we've seen throughout our journey, the universe appears to be constructed in layers, with the familiar classical reality of everyday experience resting atop a deeper quantum substrate, where time becomes fluid, space becomes negotiable, and consciousness reveals its true nature as something far more mysterious and powerful than we typically imagine. The gentle rhythm of your breathing, the soft whisper of air moving through your lungs, the steady beat of your heart marking time like a cosmic metronome. These are not just biological processes, but expressions of the universe's deepest temporal rhythms. Your body is synchronized with the quantum heartbeat of reality itself, participating in the grand symphony of existence that plays out across all scales, from the microscopic dance of particles to the stately waltz of galaxies. In learning to appreciate this synchronization, to feel your connection to the vast temporal web that connects all things, you're already practicing a form of time travel consciousness in the most profound and meaningful sense. You're not separate from time. You are time experiencing itself through the lens of human awareness, exploring its own nature through the miracle of conscious experience. The questions that time travel research forces us to confront, the nature of causality, the relationship between consciousness and temporality, the meaning of existence in a universe where all moments might be equally real. These are among the deepest and most important inquiries we can pursue. In pursuing them, we're not just trying to build better technology, we're trying to understand what it means to be conscious beings existing within the flow of temporal experience. Whether the future holds mechanical time machines, quantum consciousness amplifiers, or discoveries we haven't yet imagined, the journey itself has value. Every step we take toward understanding temporal mechanics expands our knowledge of the universe and our place within it. Every paradox we resolve, every equation we solve, every thought experiment we conduct brings us closer to comprehending the true nature of reality. And in that quest for understanding, we discover something remarkable about human nature. Perhaps meaning doesn't come from the ability to change the past or predict the future, but from the conscious choice to engage fully with whatever present moment we find ourselves in. Perhaps love doesn't depend on being able to repeat perfect moments endlessly, but on the decision to cherish them as they occur. Perhaps wisdom comes not from accessing knowledge from alternate timelines, but from learning to pay attention to the profound lessons available in our own lived experience. The universe, it seems, has already provided us with the most sophisticated form of time travel possible, the ability to be present in each moment while carrying the past forward and drawing the future closer through the mysterious alchemy of consciousness. Every breath you take, every thought you think, every choice you make is an act of temporal navigation, moving through the fourth dimension with the skill of a master pilot. In the gentle space of half sleep, as your consciousness begins to release its grip on linear time and drift into the quantum freedom of dreams, you're entering humanity's most ancient and natural time travel state. Here, in the borderland between waking and sleeping, past and future blend in ways that reveal the true fluid nature of temporal experience. The soft boundary between memory and imagination, between what was and what might have been, mirrors the quantum boundaries that might govern the deepest levels of reality. In learning to navigate these liminal spaces with awareness and intention, you're taking the first steps toward a more quantum understanding of time and consciousness. As you drift deeper into the realm of sleep, remember that every possibility you explore in dreams, every alternate reality you visit in imagination, might be a real destination in the vast quantum landscape of space-time. The universe, it seems, is far more generous with its gifts of possibility than we ever dared to imagine, offering infinite pathways through time for those who learn to see beyond the classical illusion of linear causality. The gentle current that carries you toward sleep is the same current that carries all of existence from what was toward what might yet be. You are not separate from this flow. You are the flow, experiencing itself through human consciousness, exploring its own nature through the miracle of temporal awareness. In the quiet space between one heartbeat and the next, between one breath and another, you touch something eternal, the timeless awareness that observes all temporal experience without being bound by any particular moment. This might be the deepest truth about time travel. It's not about going somewhere else when, but about recognizing that all whens exist within the eternal now of consciousness itself. As the night settles around you like a gentle blanket, and your thoughts begin to dissolve into the soft darkness, remember that you are already a master time traveler, navigating the fourth dimension with grace and skill, moving through the vast ocean of temporal possibility, one precious moment at a time. The soft whisper of night air, the quiet settling of your home around you, the distant sound of the world continuing its ancient dance. These are the sounds of time itself, carrying you forward through the darkness toward whatever wonders await in the infinite ocean of tomorrow. Whether or not humanity ever builds machines that can bend space-time to our will, whether we ever learn to consciously navigate quantum timelines, the greatest time travel adventure is already underway right here, right now, in the simple, profound act of being present in this moment, aware and grateful for the miraculous gift of consciousness existing within the eternal flow of time. And perhaps that is the most beautiful revelation of all, that time travel isn't some distant, impossible dream waiting for future scientists to unlock, but something we're already doing with every moment of conscious experience, every memory we cherish, every hope we nurture, every dream we explore in the quiet sanctuary of sleep. The soft rhythm of your breathing carries more than just oxygen through your body. It carries you gently forward, through the fourth dimension, at the only speed that truly matters, the speed of lived experience, one heartbeat leading naturally to the next, one thought flowering into another, one moment becoming the foundation for all the moments yet to come. In this gentle floating between waking and sleeping, you're practicing the most elegant form of temporal navigation ever discovered. Not through exotic matter or cosmic engineering, but through the simple, profound act of allowing consciousness to flow like water, finding its natural course through the landscape of possibility. The questions we've explored tonight about paradoxes and parallel universes, about quantum consciousness and cosmic strings, will continue their own journey through time, rippling outward into the dreams of sleeping minds, the equations of future physicists, the imagination of children who will grow up in a world where the impossible becomes merely improbable. Somewhere, in the soft darkness of tonight, a young mind is wondering about the nature of time, dreaming of tomorrow's discoveries, perhaps taking the first tentative steps toward understanding that consciousness and temporality are not separate phenomena, but two aspects of the same mysterious dance. And somewhere else in the gentle quiet of this moment, an older soul is finding peace in the realization that every instant of their life, every joy and sorrow, every triumph and failure, has been part of an exquisite temporal symphony playing out across the vast stage of space-time. The universe, in its infinite wisdom, has given us the perfect form of time travel. Not one that allows us to escape the present, but one that enriches it beyond measure. Through memory, we can revisit any moment we've ever lived. Through imagination, we can explore any future we might create. And through presence, we can fully inhabit the eternal now, where all of time converges. As your eyelids grow heavy and your thoughts begin to drift like leaves on a gentle stream, remember that you're not just falling asleep. You're preparing to enter humanity's most ancient time travel laboratory, where the normal rules of when and where dissolve into pure possibility. In dreams, you'll meet versions of yourself from different ages, visit places that exist only in the quantum realm of potential, experience events that follow the beautiful illogic of consciousness, freed from the constraints of linear time. Tonight, you might find yourself as a child again, running through summer fields that smell of honeysuckle and promise. Or perhaps you'll glimpse yourself as an elder, wise and peaceful, watching stars that haven't yet been born. These nocturnal journeys through temporal possibility are not mere fantasies, but genuine explorations of the vast quantum landscape that surrounds and permeates our everyday reality. In learning to navigate the dream state with awareness and wonder, you're developing skills that mirror those required for any form of time travel. The ability to remain conscious while reality becomes fluid, the courage to explore the unknown, the wisdom to find meaning in experiences that transcend ordinary logic. The gentle settling of your body into rest is itself a form of temporal transformation. As muscle tension releases and breathing deepens, you're shifting from the active engagement with linear time that characterizes waking life to the fluid temporal awareness that governs the realm of sleep. This transition happens naturally every night, a reminder that consciousness is far more flexible and mysterious than our daytime minds typically recognize. In the soft space between thoughts, as awareness begins to dissolve into the welcoming darkness, you touch something that has always been with you but is rarely noticed, the timeless observer that watches all experiences without being changed by any of them. This silent witness is perhaps the closest thing we have to a natural time machine, capable of maintaining continuity across all temporal states. Whether you dream tonight of flying through impossible skies or swimming in oceans of starlight, whether you find yourself in conversations with long-departed loved ones or adventures in worlds that exist only in the quantum realm of possibility, know that you are engaging in the most sophisticated form of time travel ever discovered. The navigation of consciousness through the infinite landscape of temporal experience. The gentle current of sleep carries you not away from time, but deeper into its essential nature, where past, present, and future reveal themselves as arbitrary divisions in what is actually one seamless flowing reality. Your consciousness, like a small boat on a vast ocean of possibility, will drift where it needs to go, guided by currents deeper and wiser than any we can consciously direct. As the last traces of waking awareness fade into the soft embrace of sleep, remember that you are already everything you need to be for this journey through time. You are consciousness itself, temporarily focused through the lens of human experience, but ultimately eternal, timeless, connected to every moment that has ever been or ever will be. Tomorrow you will wake with perhaps only fragments of tonight's temporal adventures remaining in memory, but something deeper will have shifted in your understanding of what it means to exist within time. Rather than being trapped by it, you are dancing with it, flowing with it, participating in the universe's endless exploration of its own infinite nature. Sleep well, gentle traveller, through the dimensions of time and space. Rest peacefully in the knowledge that every moment of your existence contributes something irreplaceable to the grand tapestry of cosmic experience, and dream sweetly of all the wonders that await in the vast ocean of possibility that surrounds us always. The soft whisper of your breath, the quiet rhythm of your heart, the gentle settling of night around you. These are the sounds of time itself, welcoming you home to the eternal present, where all journeys begin and end, where all questions find their answers, not in words or equations, but in the simple, miraculous fact of being conscious and alive in this moment, now and always.